Okay, so if you've ever tried to grab the text from a YouTube video for a project, you know it can be a real pain. But what if I told you there's a tool out there that makes it unbelievably simple? Today, we're diving into a powerhouse Python library that does exactly that. It's called YouTube Transcript API.
Just imagine you need transcripts from, I don't know, thousands of videos. Maybe you're training an AI model or doing some kind of research. The official way? Well, it means applying for API keys, wrestling with complex authentication, and then constantly worrying about strict daily usage quotas that can just stop your work dead in its tracks. It's a super common bottleneck for developers. But there's a surprisingly elegant solution, and that solution is YouTube Transcript API. This thing is so clever, it basically bypasses the official front door to get you the data you need, no strings attached. For anyone working with YouTube transcript data at scale, it is an absolute game changer. So let's take a closer look at how it all works.
All right, here's the plan. First, we're going to dig into what makes this tool so special and just so easy to use. Then, we'll pop the hood and see the clever trick that makes it all possible. We'll also uncover some of its best hidden features and talk about the one major hurdle that you will almost certainly face. And finally, we'll put it all into perspective to see exactly where it fits in your toolkit.
You know, this is a really big deal for any developer who's just tired of jumping through hoops to get the data they need. It completely streamlines the process. It saves you so much time and so many headaches because you don't need API keys, you don't need to worry about quotas, and you definitely don't need slow, heavy browser automation. And listen, this isn't some obscure niche tool. It is a well-established, super trusted library in the Python world. I mean, with over 7,300 stars on GitHub, it's been battle-tested. It's the foundation for countless AI training pipelines, content analysis platforms, you name it. That number, that represents a massive amount of community trust and reliability. So you might be wondering, how does it get around the official API? It's not by scraping the public web page. That's slow, and it breaks all the time. Nope, it taps into something way more powerful. YouTube's own internal API. The library basically reverse engineers what's known as the Innertube API. Think of it like this. The official API is the front door, right? It has a bouncer, it's checking your credentials. The Innertube API, though, that's the backstage pass that the YouTube website itself uses to load stuff like captions and comments on the fly. This library figured out how to use that same backstage pass to just grab the transcript data directly. Pretty cool, huh? And the efficiency gain here is, well, it's just massive. Instead of downloading a huge video file or firing up a clunky, slow browser just to get a few kilobytes of text, this library makes a single, tiny, lightweight request. It's like asking for a specific sentence from a book instead of having the entire library delivered to your front door. But wait, there's more. This library is way more than just a one-trick pony. It's actually packed with some seriously powerful features that solve the real-world problems you're going to face when you try to do this stuff at scale. For example, it can find every available transcript for a video. That includes manual ones, auto-generated ones, and even the auto-translated versions. It has built-in proxy support to get around those annoying geo-restrictions and session sharing to maintain logins for huge jobs. Plus, it gives you back a rich, easy-to-use data object, not just a blob of raw text. And it even has built-in formatters to export to standard formats. I mean, these are professional-grade tools, right here. But there's a catch, a big one. It's the classic, it works on my machine scenario that trips up almost every single user the second they try to move their code from their laptop to a server. This quote, it's from the project's most talked about issue on GitHub, and it perfectly captures the frustration. You spent hours building your app, it works flawlessly on your computer, you deploy it to the cloud, and poof, nothing, it just breaks. So, what in the world is going on?
Well, here's the problem. YouTube knows the IP address ranges of all the major cloud providers, AWS, Google Cloud, you name it, and it actively blocks them to prevent large-scale scraping. So your home internet connection? Totally fine. But the second your code runs from a data center, you hit a brick wall.
Now, this could have been a deal breaker, but this is where the power of open source really shines. The community didn't just give up. Instead, developers from all over collaborated, they diagnosed the core issue, and they engineered a solution together. You can actually see the whole story unfold right here. It started with these scattered reports of errors. Then, the community connected the dots and realized, hey, this is cloud IP blocking. From there, it was a group effort to build and then refine a fix, turning what was the library's biggest weakness into a powerful, fully documented feature. Okay. So after all of that, when is this the right tool for the job? because understanding its specific strengths and, its weaknesses is really the key to using it effectively.
This table really makes the choice crystal clear. Compared to the official API, setup is a breeze, and there are no quotas. And when you stack it up against tools like yt-dlp or AI transcription services, it's orders of magnitude faster and cheaper. Its sweet spot is pure speed and scale, for basically no cost, as long as you factor in proxies.
So, here's the bottom line. You should absolutely use this library for any project that needs YouTube text, fast and at scale. It is perfect for data pipelines. But don't use it if you need video metadata, like titles or view counts. And just remember, if you deploy to the cloud, a rotating proxy service isn't a nice-to-have, it's a must. And one last thing, it's worth knowing that support for age-restricted videos is broken at the moment because of some recent YouTube changes.
You know, this whole story is just a powerful reminder of the constant cat-and-mouse game that's happening in the open-source community. And it kind of raises an interesting question. As these big platforms get more and more sophisticated at locking down their data, will developers always be able to find a way in? Or are we maybe heading towards a future where access to this kind of information is just increasingly controlled by a handful of tech giants?